All right, now, as indicated at the end of the previous clip, we're going to discuss when would you choose to use the median instead of the mean. Again, the mean is our default choice as statisticians. That's, again, the most useful measure of central tendency we have. So if that's true, why would we choose to use the median instead? And there are 4 reasons for that. The first time you would use the median instead of the mean is if you have extreme scores in your data. So there's lots of ways of saying that. And we've talked about before, an extreme score is a score that's very different from the rest of the distribution. That score is sometimes called an outlier. So if our data has some outliers in it, we know that the result of that is a skewed distribution. So if our data is very skewed, the mean is the worst choice. Of all 3 measures, the mean is the most reactive to extreme scores and outliers. Let's think about it this way. Let's say I gather up a sample of 99 folks and I measure their incomes. And I go to the first person and I say, what's your annual income? And they tell me it's $20,000 a year, okay? Go to the next person, they say $20,000 a year. And go to the next person and say it's $20,000 a year. And by some bizarre coincidence, all 99 people make exactly $20,000 a year. So 20,000 plus 20,000 plus 20,000 plus 20,000, 99 times divided by 99, we know that the mean income would be 20,000 a year. Okay, that would be just fine. And now we're going to put an outlier in here. Now in comes some person that now makes $1 million a year. When I add this person to my sample, my 100th person, what's going to happen to the mean? 99 out of 100 people make $20,000 a year, but this one lucky person makes $1 million a year. The mean is going to skyrocket. 20,000 plus 20,000 plus 20,000 plus 20,000, 99 times, plus $1 million divided by 100. The new mean would turn out to be almost $30,000. The new mean with this millionaire in it would be, what do I have, 29,800. Well, this is an extreme score. This is an outlier. This is a score that's not like most of the other data. We are now having a positively skewed distribution. We have a very high score that's way the heck out there, different from everything else. So this mean of 29,800, we could just say 30,000 for all intents and purposes. Remember, there's 2 goals for any measure of central tendency. Tell me where most of the scores are. There are no scores really there. And come up with a score that does a good job of representing all of the scores. Well, if you make 20,000 a year and all of a sudden your salary jumps up to 30,000 a year, essentially, that's a big difference. That's not a small difference. That number doesn't represent everybody else. Likewise, if you happen to be the one lucky millionaire, send me an email, let me know. We can sell you a grade maybe. Just kidding. No, just kidding. But $30,000 does an even worse job of describing that millionaire, right? So if we have an extreme score, an outlier, or a skewed distribution, the mean is going to get thrown way out of whack. It becomes really a useless number to us. It doesn't tell us anything useful. So what we do instead is use the median. Line up all the numbers from low to high, 20,000, 20,000, 20,000, 20,000, 99 times, and put that million at the end. And what? Pick the number literally in the middle of the list. What's it going to be? 20,000. 20,000 tells us where most of the data is and does the best job possible of representing 99% of the scores. So if we have extreme scores or outliers or a skewed distribution, we want to use a median, not the mean. The mean would be the worst choice there. Why else would we choose to use the median instead of the mean? We might choose to use the median instead of the mean if we have what are called undetermined values. Oops. So let's say I'm running an experiment and I want to know how long it takes kids to solve some puzzle I've given them. So I give the puzzle to kid number 1 and I got the stopwatch running and it takes them 2 minutes. And go to the second kid and it takes them 1.5 minutes. Go to the third kid and it takes them 5 minutes. Go to the fourth kid and it takes them 3.5 minutes. Go to the fifth kid and it takes them 90 seconds. Right? I could average all those numbers. But I get to one of the kids and I give him the puzzle and he never solves it. He gets distracted and looking around and forgets he's supposed to be working on it, and timer's just running and running and running and running and running, and he never has a time because he never finished it. He just sort of forgot to work on it, right? Well, I have an undetermined value for that person. I don't know what that child's score would be, how long it would have taken. Their score is a question mark, basically. Well, how do I put that in a calculator? I can't put in all the scores and then write n plus 1 I don't know. But my calculator won't do that. So it's literally impossible to calculate a mean under these circumstances. You can't do it because you don't have a number to put in. But you can still line up the scores from lowest, in other words, fastest, least amount of seconds, to most seconds. The kid that never finished it would have the highest score of all. We could put that question mark way at the end because we know it would be a high value if he had finished it. And still then we can go to the middle of the list and go, the median time to solve the puzzle was. So if we have one or more undetermined values, we can still rank from low to high and find a middle. So that is working the median if we have undetermined values. It is almost the exact same idea. The third reason we would use a median instead of the mean is if we have what are called open-ended distributions. So this amounts to the same thing. Let's say we've administered a survey and we're asking people, how many times a week do you go to the gym to work out? And so you can tell me answer A is that you go 0 times a week. Answer B is that you go 1 time a week. Answer C is that you go 2 times a week. Answer D is that you go 3 or more times a week. All right, so they check whichever box applies to them. Now the issue is this one. This is an open-ended distribution. If someone says, that's me, what number is that really? It's 3 or more. They may go to the gym 3 times a week. They might go to the gym 5 times a week. They might have some sort of, obsessive compulsive and they go to the gym 14 times a week. We don't know what number that really is. So it's very similar to an undetermined value. It's a 3 or anything higher than a 3. So we wouldn't really know what number to plug into the calculator there, because it could represent 3, 4, 5, 6, 7, we don't know. But we can arrange them from low to high, all the answers we got, all the scores, and pick. So the median number of gym visits a week is. So we can still deal with that the same way as the undetermined values. We can still rank them and find the center. So we have one more reason why we would choose to use the median over the mean, but we're going to have to pick that up in the next clip.